Hello, thank you for being here today. My name is Carlos Fonseca. I'm from Positium, an Estonian company that works with mobile positioning data. So for today, we have a short overview of what mobile positioning data is. Then later we will hear from Tarajev from the Smart City Tartu on how the city used mobile positioning data to redesign their public transportation network. And after that, we will hear from my colleague Henry Turk about mobile positioning data and the use for transportation in this domain. So today, I'll just give you an overview of what mobile positioning data is and how Positium processes it to obtain insights and official statistics. So what is mobile positioning data? Most people in the world carry their mobile phone with them, and their mobile phone is constantly connecting to the network and to the cell towers of the mobile network operators. This information is stored in their servers automatically and constantly. And this information is used by the mobile network operators for billing, for example. And this information is a store, and what we do in Positium is that we process this information. This information is used for processing it to obtain the location of people, and not, but it's not used for to follow a specific people, but is used anonymized to be able to gather this information and process it with the methodological statistics processes, and use them for different domains that I will just talk to you a little bit more later. So this data is as I said, anonymized, and is processed using these methodologies that Positium has been developing for now more than 18 years, and the company has developed these processes, these methodologies with the University of Tartu. Positium is a spin-off company of the University of Tartu. So once this information is processed, this information can be then used to produce collective location and movement flows of people, and to produce insights and statistics. So Positium process this mobile big data for human mobility monitoring, analysis, and statistical indicators. And today we have just an example of that, of one of those projects with the city of Tartu. But then my colleague will also talk about other projects and methodologies. So where is MPD used? Positium uses mobile positioning data for mobility. So how people commute, for example, and how people move. Also in tourism, so to understand how many people visit certain area, how many visitors from a specific countries, and how they moved around the country. And also population, to understand how many people live in a certain place, but also where they are in a specific time of the day. So we have done around 300 projects in the 18 years that Positium has been working. Today we will be talking about specific ones in transportation, planning, and also traffic and population as well. But mobile positioning data has been used in many different projects in other domains. These projects have been done in different places like the Middle East, Estonia, but also in Latin American countries and in countries in Africa as well. So Positium works with many different international organizations, as the many United Nations agencies, but also European ones like Eurostat and other organizations and local partners as well. So who is using mobile positioning data? Mobile positioning data in the beginning, it was used mainly by researchers. So we are talking about back when Positium started. Now, mobile positioning data is used by municipalities, governments, national, local governments as well, and ministries to understand how people move and understand and plan different projects, as we will hear later from from our guests today in this webinar. Thank you for your attention to this short presentation. Now we move to Romer.
Okay, Carlos, can you see my slides?
Yes, we can.
Shall I do it with a video or without?
As you wish. As you wish.
Okay, it's no problem. It's no problem. It's not too early morning for me. So hello everyone. The first challenge I have is how to greet you, because I see a lot of people attending here around the world. So for those who is morning, good morning. For those who is evening, it's good evening. But anyway, a warm welcome and regards from the city of Tartu. Before I jump into the slides, a little bit my background. I have been working at this position for a year now. It has been a very interesting journey, knowing everything about smart city, the background, and working with companies. And I must give a credit to Positium. The project I'm going to present to you is something I'm always having in my pocket and introduce worldwide, and it's getting a lot of attention. So if you're ready, we can start. But just before I go to the public transport project we did with Positium, let me yes, very a little bit about Tartu. And I really hope that these kind of these four things you will remember tomorrow morning when you wake up. I don't want to bother you with a lot of information, but you have to understand the background of Tartu and the platform where we are today developing Smart City. The city wouldn't be smart without the university. So it is, as you see, 60% of Estonian research potential. This is coming from the University of Tartu. Is a backbone of Tartu, and we are often called as a Cambridge of Estonia. And this is our opportunity. Yes. And if you see the word startup, then you understand why Tartu has been and will be on the scene of startup scene. We are capital of startup and having a lot of events here. So Tartu is always related to startup community. And mainly because of those two first points, we are also very successful testbed for offering city infrastructure, all the data we are gathering. And we are very honored to be the only Estonian city selected for the European Union climate neutrality program. Those guests who are from city governments, but everyone else as well, please contact me later tomorrow if you have any initiatives, ideas how to cooperate or build our ecosystem together. I will be more than happy to help you. So, like every city, we have also challenges. We don't have enough experts. Budget is limited, so we have to be somehow creative. And if you would ask me, what is the first thing a city must do to really open a city for innovation? My answer would be you have to be open. You have to be collaborative, open for everything. And I think that's the reason why we have decided, and I think in a wise way, how to create the ecosystem what we have. So first of all, to really make it work, you have to contribute and invest into ecosystem. This is, in my opinion, the most important precondition to really have something to be changed and to bring changes into the city and into the life of citizens. So you see, there's many roles for the cities to play. We have a lot of incubators. We have science park. We have a very strong startup community, and this is our platform for collaboration and innovation. And it's what we have organically now happening is we have ecosystem where it's so easy to delegate tasks to different stakeholders. But the city, of course, is actively joining all discussions and initiatives what our stakeholders are planning. So let me jump to the public transport project. I think this is the best example of PPP project, and today I don't see any other way to make something big, but to use data. So data is important, and something you should maybe take away from this webinar. Using data is crucial. Like every city, City of Tartu was also facing a challenge of motorization. We had more and more cars, and the ridership decreased with the public transport. So we had to do something. And you have to understand that for Tartu, it always has been very important to be a city where you can walk, commute very easily. So we want always to have streets open for commuters, for bicyclists. So we had to do something to bring people back to public transport and use public spaces. So I'm not going to go through the challenges, and let's jump. So this is what this is the picture what we have what we had before the project. I remember from my school time, it was very challenging to catch the bus. Sometimes you missed the bus and you had to wait a long time. We had sometimes very hard to understand routes, and as I told you, the ridership went down, which was a big let's say the problem for us we wanted to solve. What Positium will explain later, and what Carlos already did a little bit was one of the data sets we used. We had a huge, we had a big project together with Positium and one of the companies from Finland. We used more than 20 data sets to understand what is the need and what is the future and how to change current public transport. So you see a lot of different data sets mentioned also here. And yeah, interviews are also mentioned, which was very important. So these are two examples. On the right side, you see the red dot, which is a school. And you see a lot of yellow dots, which is a location of pupils going to that school. These kind of data sets were used to create a new public transport. And on the left side, hugely, I think this is the big part what Positium is doing today. We used anonymous mobile data positioning to really understand how people move in the city, to make the public transport for them easily usable and accessible, so they wouldn't need cars anymore. And on the graph, you see different colors. You see the circular lines are now replaced by pendulum lines. You have more connections, more opportunities. And today I can say there is actually, you need just one change of bus and you can reach everywhere in the city. And this is hugely done or favor of all the data we gathered. The distance of the buses, what buses are covering is the same, but we have 50% of only bus lines to the old version. And something, yes, and I want also to highlight the citywide bike sharing, which was also created with the same project, with the public transport project. There's a lot of public bike sharing, we call them docks, where you can really easily get a bike. And the city's approach is that it must be affordable for every citizen. So it's really cheap to have an annual subscription, and you can use 1 hour for free, the bicycle. And as I said, we want to be a very livable city, and this is the way we bring people to the streets. This was very generally explained the project. I want to leave some room also for questions. Here are my contact details and one of the web page. You see more about Tartu, and I give the floor back, Carlos, to you, and maybe you can manage the questions now. Thank you.
Thank you, Romer. Yes, we can now have the session with Hendrik, and perhaps we can take any questions later as well. But if there is any question, well, then if not, we can move with Hendrik, and perhaps at the end people can send also their questions to the chat. And if not, they can also contact you to your and perhaps later they can get in touch.
Yes, Carlo, thank you. I didn't mention, because of the short time, that I used to be also a FIFA football referee. So we had a saying that questions come after the game. So feel free, as I told you, feel free everyone to connect me directly or through the webinar organizers. I'm more than happy to connect you.
Thank you, Romer. Thank you for your time as well today, and to explain this project. Well, we now move to Hendrik, and also if you have at any time any questions, you can also leave them in the chat as well. Okay, the floor is yours, Hendrik.
Yes. Hello, everyone. My name is Hendrik. So I work in Positium, and so I'll just do a quick presentation about how we use mobile positioning data for transportation and mobility purposes, the methods that we use, and then just a couple of case studies as well. So as was said earlier, mobile positioning data is data that is stored in the cell towers, so mainly collected by the mobile network operators for billing purposes. And so we take these billions of location points, and using our Positium data mediator software, we transform these into meaningful statistical indicators. And yeah, this can be used in various fields: spatial planning, population statistics, transport modeling, event statistics, disaster management, and a lot of other things. So the methods that we use are quite complex, as you can see here, to ensure a high accuracy and just high quality statistics. And these have been developed over the years along with the University of Tartu. And so the first thing I'll mention is that, for transport as well, we need to know people's home and work locations and other locations where they move. So we use anchor points. So for place of residence, we algorithmically determine people's home locations based on where the mobile phones are used in certain hours of the day and certain days of the week. And so we can determine home locations, and a valuable thing is we can also determine secondary homes. So if there's cottages or people stay a lot with their relatives, then we can determine second home locations as well. And so the same is true for work anchor points. So we can determine based on time of day and time spent in a certain location. We can establish these as work locations. Also, we can establish up to 2 work anchor points. And this is very valuable because this is often data that otherwise is extremely difficult to get, where people actually work and where the population is present during work hours. And then we also have other anchor points, which are just other frequently visited places that we determine are not home or work locations. With the home anchor points, this has been validated in research as well, where volunteers were offered to, gave permission to use their mobile positioning data. And so where we could map out algorithmically their home locations based on our methods, and then compare it to the actual homes where they lived, and the results were found to be very accurate. But because the data is stored in the cell towers, this means that on its own, the data only exists at the cell tower accuracy level. So in dense urban areas, cell towers might be a couple of 100 meters from each other, and in more rural places, they'll be more sparsely populated. So of course, we want to increase the spatial accuracy beyond that. So then we use various spatial interpolation methods to make it more accurate. Things like creating coverage areas based on algorithms, using adaptive grids, and then also reference data such as road, building, and land use data. So as an example, if you have a coverage area where the phone is used and there's a highway and then there's a smaller side road, then we can say that there's a higher probabilistic chance that the location of the user will be on the highway compared to the small road. Or if there's a dense cluster of buildings compared to a more forested area within the coverage area, then again, there's a higher probability that the person will be located in the dense cluster. So it's quite a lot of different things to increase the accuracy. So all of this comes together to form our continuity model, which represents people's spatiotemporal activity and in totality. So we might have like people stays at homes, then they're commuting from home to work, they stay at the work, then maybe after work, moving from there to a shop, and then staying at the shop, moving to a second home, and so on. So we can get a very good overview of people's mobilities. Here's just an example of, this is Tallinn, the capital of Estonia. And so the blue triangles here are the locations of cell towers. And so you can see where there's a more clustering of these, then these are more densely populated places. And so just for this example, there's a person whose place of residence has been determined to be on the upper side of the image, POR, and then the work is in the middle of the image where the dense cluster is, and then this person commutes from home to work, and their phone connects to different cell towers on the way, and so based on that we can create an image of how they commute, which routes they take, and so on. And for example, after work they might go to another frequently visited place, which is on the bottom left side more, and yeah, we can map out all these different kinds of movements. So one thing that's very valuable about mobile positioning data is the facto population, so that you can measure the population at any point in time that you'd want. So it can be any time of day, any day of the week, and so you can really get access to data that otherwise might not be easily accessible. So for example, and the population can change very fast. So in a busy office business district, it could be that the population is very large during work hours, but then in the night there might be barely anyone there. So there's an example of valuable kind of data we can collect, or comparisons between weekdays and weekends, or yeah, different seasons, different months, and so on. So another case that, yeah, I'm not going to talk about the Tartu case because Romer already summed that up nicely, but another case that we've worked on was the North Tallinn mobility study in 2014, where, so in this case, the issue was that North Tallinn, so a district in Tallinn, was rapidly developing. It was a popular place for people to move to, and so existing access routes were under stress during rush hours. And so the city of Tallinn required mobility data in this district in order to better plan new developments and the infrastructure there and transportation connections and so on. And the city considered different methods to map out this mobility, including surveys and traffic counts, but in the end they chose mobile positioning data because it had more upsides compared to the others. So here's some examples of indicators we were able to give. So this is the district of North Tallinn. So able to map out again the places of residence, the places of work. You can have like movements between home and work locations. In this specific case, it was done the sub-district level, so you can see movements between the sub-districts here. But in other cases, you can also use origin destination matrices to map out the specific routes and such. And you could also map out the movements for people who lived in North Tallinn, but who worked outside, so in different other districts in Tallinn, or even other neighboring municipalities. And also the reverse, people living in other districts and commuting to North Tallinn. And you could also map out the movements between home and leisure locations. So there were a lot of different indicators that it was possible to gain access to using this data. And so, yeah, when the city of Tallinn considered doing mobile positioning data compared to surveys, some of the upsides that they presented was that the mobile positioning data sample, in this case, was 35% of the district's population, compared to roughly 1% if they would have done a survey. So in this case, the data was accessed from a single mobile network operator who had a market share of around 35% of the people in this area. So another upside was that the time scope was 12 months, so a full year's worth of data, rather than 8 days or so that it would have been if they would have conducted a survey. or if they would have wanted to do a year-long survey, that whole process would have probably taken around 15 months, where designing the survey would take 1 month. Then of course they would need to collect the data for a full year and then analyze it for another 2 months. For this project with mobile positioning data, the whole process took only 2 months because the data was already there. It's already stored in the mobile network operators. So you can get the last year's worth of data, and then the processing and analysis took 2 months. One thing to note, of course, is that in this case, the data negotiations with the mobile network operators had already taken place previously. This was not part of this project, but often you'll need to negotiate with the mobile operators, so that will take some time as well. And then another added benefit is that the mobile positioning data measured the full extent of actual movements, and it did not rely on the memory of respondents, which is not always the most accurate. So a different case that we've worked on was for the Oman National Statistical System. This is a fairly new project, and so where mobile positioning data was used for official statistics in different domains: population, commuting, and tourism. And in this case, the data was accessed from 2 mobile network operators who formed the entire population or market share in Oman. So we were able to get the whole country, essentially, the whole, everyone in the country and their mobilities. And so here's just an image of Oman, and there were, again, a lot of different indicators: the home locations, secondary homes, main daytime, so like work or other such locations, other regular locations, among other things. And then you can map out commuting and such. And I think one thing that I'd like to highlight is that mobile positioning can be used on very different scales for very different kinds of projects. So you can use it in like a specific city district, just focusing on mobilities within that district, or city level, regional level, national level, like Oman. You can see commuting between different municipalities, or seasonal changes. If people live in one part of the country during maybe warmer parts of the year, but then another part during colder parts, or weekend getaway. So there's a lot of very rich data and measurements of mobilities that can be gained. And these can, of course, be used for a lot of different purposes, such as more efficient transportation planning, such as was the case with Tartu, or if on a national level you need to build new roads and understanding where the demand is, where people are moving at what times, or upgrading or maintaining existing roads, or other things. So there's a lot of different options possible. And that was my presentation. Thank you.
Thank you, Hendrik. Just ask you, Hendrik, about some of the things that you presented in the. How is it possible, for example, to use MPD to, for example, plan a road, or what kind of what kind of part can play MPD can play in the planning and implementation, let's say, for example, of a road or a project?
Mm-hmm. One thing is that mobile positioning data doesn't measure vehicles or traffic in that sort of sense, but it measures people and where people move, for example, within the city. And so you can already just map out the demand of where people need to go at different times of day, for example, and that can always be compared to like what the city or municipality or government is providing. So if there's a lot of movements between certain places, but there's not much public transportation, then that can be an example of where they can see that where they need to improve the public transportation connections, or sometimes it can be even like in different times of day, like maybe there's need to be improvements to nighttime public transportation options, or other things like that.
Okay. Sorry. So we also have a dash also just elaborated a little bit more on the question, and we have here with us also Erki Saluber from Positium. Erki, could you maybe elaborate on this on the question from Dash, please?
Thank you, Carlos. So maybe I can answer, as the question is quite broad, that what you asked, if I understood correctly, but the question is very relevant to the topics today. So how can mobile positioning data help to manage congestions in the cities? And that goes in different ways, how that can be done. So what we heard previously, the example from Tartu city, that is one part of this congestion management as well. So improving the public transportation offering in the city is one form how to overcome the congestion topic in a city. So all the kinds of methods that go into improving the public transportation offering to the city are very relevant to overcome the congestion problem. And in order to do that effectively, you need to understand how the city behaves currently. So you can't only build an ideal city on paper, but you have to analyze as well how the people are moving. And the best data source for that to understand is the mobile phone data, as well, basically every person is a sensor in the city, and to aggregate that into statistics, you can see the real movement patterns. And you have to design the public transportation in accordance where people move, and that will change over time as well. So it's like a constant input that you need to put into. But there are, of course, other aspects of it as well, how MPD can help overcome congestions in the city. Another part is that cities are building different infrastructure projects to leverage congestion problems. That includes preliminary studies of where to build new infrastructure. And again, you have this input, which is needed, is this MPD statistics, how people move in the city, in order to understand where to, or what kind of cost benefit analysis will tell about particular infrastructure object investment needs and their kind of possible benefits that you would get out of them. And later on, even if you have done the investments, and all the cities, of course, they do all the time investments, you should monitor over time as well how the investment really worked out. So, for example, all the preliminary studies, they include these estimations of how many people should use those infrastructure projects. For example, you build a new bridge, or you build a new highway, or as well, for example, you actually take some roads away from cars, and you estimate what kind of effect they would have on people mobility. And again, in order to see if those investments really went the way how they were planned, you need to analyze the movements after the investment. So this is like a monitoring phase of the investment in order to learn from that and then make better decisions in the future. So, and those are only few examples where the same data source could benefit different aspects of overcoming congestions. And of course, I could talk a bit longer here, but I will stop. I hope it cleared some of the questions you had, Dash. Thank you very much.
Thank you for that. Well, we actually have reached the time that we had allocated for the webinar. Of course,
Carlos, we can't hear you, or is it me only?
I can hear.
Yes. Okay. Yes. Thanks. No, I was just well, just saying that we have reached the end of the webinar because the time that we have allocated. Let me see. So we will send you, as I told you, a recording of this webinar. We hope that in the future we can continue also not only by writing the blogs in positium.com. You can find more details about these methodologies and these processes that Hendrik and Erki talked about, as well as other materials. And we really appreciated that you took the time to join us in this webinar. I want to once more say thanks to Romer and to you, Hendrik, as well for today. And also, you can send us other questions, and we can engage and interact with you in other ways through LinkedIn or through email as well. So thank you for attending the webinar today. And so sorry that time was short, but for sure we can go more in depth in these subjects later on. So thank you, and have a good day.